Linear function is one of the most useful things for everyday life. It's unbelievable how many things are modeled as simple linear functions. To give you a very basic example, before cell phone plans had like unlimited minutes and stuff, you used to be charged by like overage, and some plans still have overage charges and stuff. And the way a cell phone plan would work would be you would pay a monthly premium, so say it was like $40 a month for X amount of minutes, and for every minute you went over, you paid an additional like 30 cents or something like that. Something ridiculous, the fee they didn't charge you. But the way that works is based on a linear function. The initial value that you're paying, the $30 a month, is your y-intercept. That's what that really is. It's the starting value, the y-intercept. And the slope is the rate per minute. So if I were to graph the scenario that I was just talking about, if I were to graph the scenario I was just talking about right now, and it was $30 a month to start, and this is the amount of minutes over, okay? And if you had 0 minutes over, well, it's just $30. Right? That's all it is. If you didn't go over it all, that's all it costs. But if you go over, say, like every minute, I'll go by fives here. You know, maybe now it's up to, let's say it's 20 cents per minute to make it easy. This would make this 31 up here. This next line dot would be at 31. Because if you go over by 5 minutes, right, and it's 20 cents every minute, that's another dollar onto your bill. So that would be another $31. And then if you go over by 10 minutes, it'd be $32. If you go over by 15 minutes, it'd be $33. So the idea behind this is that you have, as a result, a linear function. Okay, a linear function. The way I would write this would be this. F of x equals 0.2 for 20 cents, right? 0.2 times x plus 30. Again, identifying this is your starting value. This is your slope, or your cost per minute. It's 20 cents per minute. And the units of x are in minutes. This kind of a problem is very useful to keep track of your units throughout the problem. Let me explain. Here, the units of f of x. So this is our f of x axis, right? Like our y-axis. This is our x-axis down here. The units of f of x are dollars. I'm just going to put the units down here. What are the units of 0.2? What are the units on 0.2? And that's not very obvious, so it's might you have to think a little bit here. What are the units of 0.2? All right, just if you're struggling with that, what are the units of x? What are x's units? Just look on your x-axis. What is it labeled as? Minutes, or minutes over, but let's just say minutes as a unit. So x's units are minutes. Okay, what are the units of 30? At the end, at 30 there, Paul? Yeah, so what do I put? Dollars, right? The units are dollars. It is money, but it's dollars. So what are the units of 0.2? Kelly?
Is it still money?
It's not. It's close though. It's not money. Because the units wouldn't make sense, right? If I put a dollar sign here, and I say money equals money times minutes plus money, the units don't match up. You need the same units on both sides of the equation. What for how many minutes? Go over. What are the units though? What are the actual units for 0.2? What's the units I should put right here? X. If I were to say like 0.2 what? 0.2 what? How would I label 0.2?
Well, it's like the amount, it's the cost for the amount of for each minute that you go over.
So what are the units? Yeah, cost per minute over, so what would the units be? Cents. It's 0.2, so you're still in the same units of dollars. You don't have to change the cents. If I think about this, right, and I have minutes here, this has to be dollars per minute, because the only way these units are going to work is if these minutes cancel, giving me dollars plus dollars equals dollars. Now, think about 20. You were on the right track. You have trouble explaining. It is per, and you and Charles said cost per minute over. But the units are dollars per minute. And think about it. This is telling you $0.2 per minute times the amount of minutes plus $30 gives you the total in dollars. So whenever you're doing these kinds of word problems, the units on the left-hand side of the dependent variable, f of x, these units of dollars in this scenario, have got to be the same thing that you get at the end. of canceling all the units on the right side. Alright? So we had minutes here. So I knew, just because I knew, obviously I'm teaching this, but I also know because I'm looking and I'm saying, minutes are the units that I want to get rid of it for x. So the units of 0.2 have got to have minutes in the denominator. I want to get to dollars, so it's got to have dollars on the top, and that makes sense. This tells me $0.2 per minute. Well, that's the overage charge. That's what Charles was talking about, the cost per time. Okay, it's the cost per time over in this scenario. What's another example? What's another example of a function that is linear you can give me? And you can talk about the y-intercept and the slope. What's another example? There's so many, guys. Try and think about like on the way to school, or think about like costs for certain things. Cost is an easy one to use.
Every time you wash the dishes, you get paid $10. If you wash an extra dish, you get 50 cents.
All right, perfect. So if you get allowance from your folks, right? And they say if you do all the dishes, you get, what do you say, $5 or $10? That's a lot of like dishes. But yeah, that's awesome. That's a lot of dishes. Say you work on these dishes for like 2 hours, you get $10. But for every extra mug, coffee mug that you do, you get 20 cents or 5 cents. Okay? So let's model what that would look like. All right, so here we've got, let's use g of x this time, it doesn't matter, right? We know that you're getting $10 to do the dishes no matter what. So that's over here. And then we're getting 5 cents for every extra coffee mug that we do. So how could I write that? 5 cents per coffee mug. How would I write that?
0.05.
Now, what is x? What is x defined as in this problem then?
The amount of coffee.
Yeah, the amount of coffee mugs you clean. And g of x? And g of x, Kelly?
The total money you earn.
Yeah, the total money earned. All right, so follow it up again. Let's take a look at this now and say, what are my units? What are my units? It's similar in some aspects to the last problem, right? But then there's some things that are different. What are my units of g of x? Let's start with that. G of x, what should the units be of g of x? And if you don't know, look at what g of x is, and then you can figure out what are the units for that idea. What do you got, Paul? Dollars, very good. All right. How about the units of x? We'll make it easier first. Let's do the units of x. If I said x was 5, that means there are 5 what? Coffee mugs. I'm just going to put mugs for now. Coffee mugs. Good. The units of 10. The units of $10. Right? Units, dollars. Ideas, man. Dollars. It's got to be dollars. Whenever you're adding something, if you're adding a quantity by itself, it's got to be the same as what you had for the dependent variable g of x. Right? Dollars has to equal dollars plus dollars. So what should the unit of 0.05 be, Mike?
Dollars divided by dollars.
Yeah, dollars per mug. And what I notice again is that mugs cancel, resulting in dollars equals dollars plus dollars. So I am dimensionally correct in this problem. In physics, when you're a junior, you're going to hear about a term called dimensional analysis. And all it means is just checking your units to make sure that they're right about the problem. Okay, so if you're measuring something in kilograms as a mass, that you're consistent with kilograms around the problem, and at the end they all cancel out and reduce. So that's what we're doing each time for this. All right? Okay, let's take a look at an example now from your notes. So let's flip to the first slide. And this first one we're going to look at is using function definition, not using a word problem first. And I want to talk about this one before we get to word problems. You want to be like, all right, I really got this down, I understood this, and I learned this. This is probably it. This is probably one of those most important kind of topics. You're going to see that for like, remember systems that we did? Another one that's really important. Using substitution elimination, it just keeps occurring over and over again. This is another one that's really useful for real life applications. So let's quickly take a look at this idea and say, well, f of x is really mx plus b. We know that, right? And what do we know as slope in the past? What have we called slope? How would we define slope usually? Yeah, m is really the rise, which is really the change in y, over the run, which is really the change in x. Well, that's what we're defining that in the top as. Remember, f of x, g of x, k of x, any of those definitions are just y, the dependent variable. Okay, again, if you see f of x, or g of x, or k of x, think of it as y as a dependent variable. So in this case, instead of putting change in y over change in x, we put the change in f of x over the change in x. So this is the only difference. This f of x has taken the place of y, but it's identical to what we've done already. Right? It's just a different way of writing it. Find equations of linear functions h and k. Okay, h is part A, k is part B, using the given information. What is part A telling me? What is part A giving me? They're giving me information. If I told you, well, h of 3 is equal to 2, what does that actually mean? What does that actually mean, Nina? Yeah, so what is the domain for this one, for this first thing here? What is it telling me? When the domain is 3, the range is 2. I like the way you put that, Nina. I never thought of it as domain and range. I always say x and y coordinate. But that's exactly right. Nina's saying when the domain is 3, the range is 2. Which is really just giving you a coordinate. Please, put that in big letters right now if you didn't click right away. Whenever you're given something that says like h of 2 equals 7, it means you're at 2, 7. H of 10 equals negative 5, you're at 10, negative 5. It's giving you a coordinate. It's giving you a coordinate. Okay? So what about the second part? H of 5 equals 7. Well? Yeah, when the independent variable is 5, or the domain is 5, the range is 7. Be careful, it's not when h is 5, okay? So when the independent variable is 5, maybe say x, right? When x is 5, y is 7. So for part A, I've got 2 points. If I've got 2 points, what can I do? How can I find a function if I have 2 points, Charles?
You found the slope?
Yeah, go ahead and find the slope, please. What do you get for a slope as a result here? What do you got, Paul?
5 over 2.
What is it?
5 over 2.
Others agree? 5 over 2? Okay, so once you have the slope now, you can say f of x equals 5 halves x plus b. Right? F of x equals, or h of x, sorry. H of x equals 5 halves x plus b. Well, what's b going to give me here? How are you, sir? Good. You were with Miss Coop?
What? No, I was at Dr. Spotman.
Ah, okay. So, how do we determine what b is in this problem? How do we figure out what b is? We did this in the last test. You see almost all hands. Luca, what do you got?
0 for x, right?
Yeah, that's 0 for x. Kelly?
Point something.
You don't have to go to point slope for him. There's an easier way. Charles?
Just pick a coordinate and plug it in.
Pick one of the 2 coordinates and plug it in and solve for b. Remember, this h of x equals 5 halves x plus b. Where did the 5 halves come from? It came from those 2 points, didn't it? So those 2 points must satisfy this equation. Because if you come up with 5 halves as a result of those 2 points, these points have to be able to fit in here. So for h of x, that's really y. So which coordinate do you want to pick? It does not matter which coordinate.
7.
Alright, so 5, 7. So 7 goes in for h of x, and 5 goes in for x, and then solve for b. Go ahead. What do you got for b? What do you got?
Negative 5.5.
Negative 5.5. Okay, some of you might have gotten negative 11 over 2 if you kept it in fraction form. Same thing, obviously. All right, so that's the b value. Am I done? Have I written a function yet? I haven't written the actual function out with all the information. Now I have m and I have b. So I can write the final function out now. All right, and that's my answer for part A. So remember, when you're looking for the functional representation, it's the same thing as finding a slope-intercept form, right? This is identical to slope-intercept form. That's all you're really doing, but now you're thinking of h of x as y. It's the exact same thing, but a different way to write it. How about part B? Let's read part B together. It says that k of 0 is 4, right? K of 0 is 4, and an increase of 5 units in x causes a decrease of 10 units in k. What the heck does that mean? Because it's not coordinates anymore. I mean, maybe you're given one coordinate, but there's something else that's kind of like fancy about this one.
K minus 10 times positive negative 5.
No. Luca, what do you got? Say again? What is the slope?
An increase of 5 units in x, decrease of 10 units in k.
Yeah, this is all about the slope right here. That's what this is. So let's take a look and think about this. If I were to graph what this looks like, an increase of 5, I'm going to pick a random point. Well, let's pick the point 0,4, right? We're given the point 0,4. So I start with that point 0,4 on the y-axis. An increase of 5 units in x, increase means go to the right, causes a decrease of 10 units in k. Increase of 5, decrease of 10. Increase of 5, decrease of 10. That's physically what's happening. So it's helping you get the slope for this problem. Okay, it's helping you get the slope. So for part B, if I remember, my slope is defined as my change in my function over the change in x, right? Like delta y over delta x. And we're told that an increase of 5 in x causes a decrease, negative, of 10 in the k. That's physically what it's saying. It's saying that when k, or when x changes by positive 5, the k value goes down by 10. So what do you get as a slope as a result?
Negative 10 over 5.
Yeah, or just negative 2, right? So our slope is negative 2. So far so good. We've got a slope of negative 2. So that tells me that k of x equals negative 2x. What's the b value here? Right away. You don't need to do any math. Read the other part of the problem. Read the other part of the problem. Okay, if I go back up and look at this and I see k of 0 equals 4. Mike? It's just 4. What does k of 0 mean, Mike? What does it mean it's doing? What are they doing? They're putting in 0 for what? Yeah, so you're getting the what? When you plug in 0 for x, you always get the... When you plug in set x to 0, it gives you the...
Y-intercept.
y-intercept. Y-intercept, okay? Remember, when you set, to find the x-intercept, set y to 0. when you want to find the y-intercept, set x to 0. So when you're told that k of 0 is equal to 4, this is really just the y-intercept. So you can just put a plus 4. So there's no need to go through the problem. Sure, you can do it. You can plug in 0 here, right? Put a 0 here, put a 4 here, and leave that as b. You'll get b equals 4. Right? You can take that coordinate, 0, comma 4, plug in a 0 right here, plug in a 4 right here, and you get 4 equals 0 plus b. So as a result, b ends up being 4 anyhow. But remember that if you're ever told k of 0, or h of 0, or g of 0, what they're giving you is the y-intercept, the starting value in the problem. Okay, the y-intercept. Does that make sense? Okay, so if you were told, like, the position of an object at 0 is equal to 20, it means that if this is the origin right here, in the beginning of the scenario, the problem starts, or the person starts 20, whatever, let's say feet, to the right of the origin. And then maybe the person moves left or right based on the slope. But it's giving you a starting location, like a stock market value. If you buy a stock today, maybe the value of the stock is like $30 per share. Okay, that's, in your time, that's where you began, $30 per share. Then what happened as a function of time, it fluctuates. But your starting value for you on the day you bought it would be $30. It's called y-intercept. Alright? I'm not going to give you work to do tonight. We're about to finish class anyway right now. I want to finish this tomorrow. Tomorrow's a C day, which means we have 32 minutes. So we'll probably have just enough time to finish this tomorrow in class. Okay, then over the 3-day weekend, you're going to have your regular homework for 3 nights. I might give you like a worksheet with 3 problems to bring home just to practice more word problems. Okay, but I'll do that tomorrow with the other stuff.